So Hyperloop is originally Elon Musk's idea for a transit system. The original plan was to get you from one place to another as fast as possible and as cheap as possible and as environmentally safe as possible. Hyperloop tries to get you to move at hypersonic speeds in a controlled environment. The way you control that environment is creating a vacuum tube and putting a pod-like vehicle inside. And underneath that air pressure, you can reach hypersonic speeds much faster. You could travel somewhere that takes about 4 hours and cut it down to 15 minutes.
Speeds in excess of 1,200 kilometers per hour are the ultimate Hyperloop goal. In August 2017, with 24 universities from around the world competing, the SpaceX test track saw one entry hit 324. Texas Guadalupe never got a chance to race their pod for glory, but they did still manage to turn plenty of heads.
We won the Innovation Award for our levitation systems. Many teams have moved on to magnetic levitation. We were the only team there that had successfully built a completely air-levitated pod that was able to flow frictionless in the controlled environment.
As complex as this Hyperloop pod looks, the key difference that you should probably know is that this levitates on air bearings. And what's so neat about this disc, we've got 4 of these underneath the Hyperloop pod, and they can lift 2,000 pounds each. And it functions actually a lot like an air hockey table. You put some air through these and it creates a thin layer that all of it rests on. It actually comes from warehouse applications, so moving around heavy weight, but a good amount of this Hyperloop pod, from the pneumatics boards to these little hop tanks on the 4 corners, all of it is optimized to help these go at high speeds, such as 200, 300, 400 miles an hour.
Somebody close these valves.
Reaching high speed is the team's next big challenge.
All right, perfect.
Today at their campus track, they're running a simple but important test.
What we're looking at right here is our ride height sensors, our laser optical sensors, and basically what we're testing is our ride height as we're moving unloaded without any extra added weight. And then we're going to run the test again, and we're going to have a couple of us stand on top of it, add a little bit of weight and loading to it, and see what the difference is.
All right, guys, let's levitate.
Alrighty.
And go.
For this year's competition, every team must design a propulsion system to push their pods through the vacuum tube. Texas Guadalupe's plan: build a small drive wheel that rides on top of the track's central I-beam.
Load the pod.
This test is step 1 in determining where to mount that drive wheel to the pod.
Turn on levitation. And push. Let's go.
It's extremely important because we want to make sure that we're not negating the effects that removing friction using air levitation is doing, because that would be the entire reason to get us to that speed.
As the pod moves, the laser sensors track the levitation or ride height at all 4 corners. Each corner should be roughly equal and remain stable for the full test run, no matter what external forces are applied.
If our levitation system works perfectly, there should be no changes based on the uneven loads that we apply. The uneven loads kind of simulate the forces that are going to be applied when we propel ourselves forward. We saw no changes, so test successful.